generative models, generative adversarial networks, they are famous for generating artificial images, synthetic text, then artificial speech signal, whatnot. If they are shown adequate examples of some particular data item, they can give rise to such data items artificially. So I'm not going to bore you with the details of this GAMO. So in GAMO, what we do is we use such a generative adversarial network to actually, this is what we are doing. This red class is the minority class. Within the minority class, we are in the image embedded space or latent space. Within that minority class, we are generating multiple green classes at the artificial points. We are generating such artificial points so that the classifier may come up with a good decision boundary like this between this green and the orange regions. So this GAMO is already quite well cited, and it has inspired certain other developments which came in top-notch conferences like IEEE CVPR and ICCV in the later years. Nowadays, what people do is they try, so I'm not going to bore you with all these things. So this is the small disjunct situation, another subpart of class imbalance handling, where there may be multiple clusters of similar objects within the same class, like different varieties of apples. I gave this example at the beginning. So we have a lot of things inside class imbalance learning, like can we simultaneously reduce from the majority class and increase the points in the minority class by converting majority data points to minority data points using a neural network type interface that actually gives you simultaneous oversampling and undersampling. Standardized and uniform benchmarking of class imbalance datasets is still out of our reach. Proper nomenclature and appropriate performance metrics for different scenarios, even when the underlying class conditional distributions are changing, these things have not been researched, especially the effect of class imbalance in semi-supervised learning, where available class labels are very few. That part is also missing. So class imbalance handling is a very big problem in practical machine learning, and it is still in its infancy. Lot of things to be done, especially in this era of deep learning. So with this, I would like to conclude, thanking all of you for your kind patience. If you have any questions, you can go on. Thank you very much.
Thank you, sir, for giving us an insight on this class imbalanced machine learning. Since I am from maths background, so I was very curious about that thing which you discussed in the early slides. Overall, in machine learning, we need to develop a function from X to
Yes.
Y. So, but I wanted to know how challenging is developing such a function in the case of class imbalanced, because the cardinality in these cases in domain and codomain is significantly very different. You already gave us an example of credit card where 40 million and the 5,000. There's a huge difference. So how really it's challenging to develop such a function so that we can predict something?
Yeah, thank you for the question. It's a very contextual one. In fact, if your minority class, let's say the whole business of machine learning, can you see the board behind me, this board? You can pin my image.
Yes, I can see.
You can pin my image and try to see the board. The whole business of machine learning is you have one class like this. So all points of the class will be generated from this region, and all points from the other class will be generated from another region like this. Now, if one class has many points which are uniformly distributed within this region, then by looking at this point, statistically, you can, only by looking at this point, you can estimate this region, this probability density function, up to a certain error threshold. There are proofs for that. But if in class imbalance situation, even if you have very small number of examples, but those examples are evenly distributed, if this happens, very few examples, but they are kind of evenly distributed, till then you should be able to find out this sort of a region statistically. You can estimate their spread. But if there are very few points, like only 2 points, which are not describing this whole volume, if it is like this, From these 2 points, you have no idea. In that case, all machine learning algorithms will fail until you have more data or more information. Okay. And if you have more than that, but they are concentrated on a very small region, okay, you want to do a, this is the biased sampling actually. If this situation appears, then also most of the machine learning algorithms will fail. All will fail actually, because they have no idea about this region of space from where new test points can emerge. So these are the two situations. In case of a minority class, the size could be less, but if the points are evenly distributed, that means points are covering the entire data space, then you can draw some inference. It's like opinion poll, let's say after an election, you only interview a very particular social group. You only interview the professors. Whom do you want to see as our next minister? So you get a biased answer that doesn't reflect the opinion of all people in your parliamentary constituency. Biased sampling is like that. So in those cases, we don't have any answer. You need to correct your data. Machine learning completely depends on the data. If the data is irregular, if the data is falsified, if the data is not clear, however intricate algorithm you may come up with, it's going to actually fail.
That's very true, very true. Actually, I find it very, very interesting. Participants, if you have more questions, you may please ask, or if you can type in the chat box, I'll narrate it for you. I believe there are none. So I think if there are more insights, you may write to Professor Das as well. He will be happy to reply, because many times I write him and I get the frequent replies. Thank you, sir. Thank you for joining.
Thank you. Thank you very much. Thank you, Professor Kim and others. Have a good day.
Thank you. Hope to see you soon.
Same to you, Professor Yadav. Hope to see you soon. Sure. Thank you, Professor Kim. Let's meet at some other occasion.
Okay. Professor Yadav, thank you.
Thank you. Thank you, Professor Kim.